Welcome to Mr. Chalk's Revision Tips. In this video, we will look at nuclear power stations, nuclear fission, and chain reactions. Nuclear fission is the splitting of a large atomic nucleus into a smaller nuclei. In addition to the dot products, 2 or 3 neutrons also explode out of the fission reaction, and these can collide with other uranium nuclei and cause further fission reactions. This is called a chain reaction. So nuclear fission of an unstable atom splits into 2 or more smaller pieces that are more stable and releases energy in the process. The fission process also releases extra neutrons, which can then split additional atoms, resulting in a chain reaction which releases a lot of energy. So if we're looking at describing the process of nuclear fission, key things to talk about is that we've got a uranium nucleus generally that absorbs a neutron. It then splits into 2 smaller nuclei and releases 3 neutrons and energy. Nuclear fission, like we've just said, is the splitting of large atomic nucleus into smaller ones. In a nuclear reaction, a slowly moving neutron is absorbed into the nucleus, so typically of uranium-235. This causes the nucleus of uranium to become or have a mass of 236, which makes it unstable. So the entire nucleus splits into 2 large fragments called daughter nuclei. In addition to the daughter products, 2 or 3 neutrons also explode out of the fission reaction, and these can collide with other uranium nuclei and cause further fission reactions to take place. The fast-moving neutrons carry most of the energy from the reaction, but before the neutrons can collide with fresh uranium nuclei, they need to be slowed down. Nuclear power is the use of reactions that release nuclear energy to generate heat, which most frequently is then used in steam turbines to produce electricity in a nuclear power plant. Nuclear power can be obtained from a nuclear fusion, nuclear decay, or nuclear fission reactor. A fission reactor contains a number of different parts. So it contains nuclear fuel. So this is generally uranium or plutonium isotopes, which split when triggered by an incoming neutron. The fuel is held in rods so that the neutrons released will fly out and cause other nuclear fission in other rods. You have some sort of moderator, which is a graphite core. So a graphite core, for example, slows down the neutrons so that they are more likely to be absorbed into a nearby fuel rod. You have control rods. These are raised and lowered to stop neutrons from travelling between fuel rods and therefore change the speed of the chain reaction. You have a coolant, so this is heated up by the energy released by the fission reactions and is used to boil water and to drive the turbines in the power station. And you'll have a large concrete shield. So the daughter products of the fission reaction are also radioactive and can be hazardous. So shale gas is natural gas trapped in rocks. Shale gas can be extracted by a process called fracking. There is some evidence that fracking causes minor earthquakes. Burning shale gas adds carbon dioxide to the atmosphere. So describe the advantages of nuclear power in comparison to burning shale gas. So some of the things that you might want to put is that no carbon dioxide will be emitted, so it won't lead to further global warming. Nuclear power doesn't cause earthquake. Also, nuclear fuel rods will release a lot more energy per kilogram of fuel. So generating electricity using nuclear reactors carries a high risk but offers high rewards. So in operation, a very small amount of nuclear fuel will constantly generate a very, very large amount of electricity and generate very little polluting material. So the financial costs of building and decommissioning a nuclear power plant are very large, however, and the waste production will remain radioactive for many, many thousands of years. So we're looking at stating two environmental issues caused by generating electricity using nuclear power plants. Some of the things that we might want to think about is that we've got radioactive waste. The waste has a long half-life. The waste is toxic, so it needs to be buried. There can be the risk of large catastrophic accidents, and the fuel is still non-renewable. Nuclear fission, like we've just said, is a splitting of a large atomic nucleus into small nuclei. We can go on and have a chain reaction that can take place. So in a nuclear reactor, a neutron is absorbed by a uranium nucleus. So this causes the uranium to become volatile and unstable. So the entire nucleus splits into smaller fragments and energy and neutrons are released. So these neutrons can further go and collide with other uranium nuclei, causing a cascade reaction or a chain reaction.
Thanks for watching.